is Michael Oliver, and I am the head of marketing at Client Server in London, in the UK. And every episode of Talking Tech, we like to meet some of the movers and the shakers from around the United Kingdom and within the tech sector, the people who are changing things and doing things in new and exciting ways. But we also like to kind of explore beyond our geography and speak with people a little bit further afield. And our guest today is certainly someone who you'll identify from his accent is certainly not from around here, but is doing some really exciting things in the world of the cloud. But he's also got a really interesting backstory as well, which we'll go into there. So I'd like to welcome along to Talking Tech, Hakim Weatherspoon. Hello.
Hello, Michael. How are you? And how is
Very well,
everybody?
thank you. Very well. Great to have you along. Your journey into software development is notable, and I think it's notable in the sense that it's perhaps a little bit unorthodox in terms of the way people think about how people get into this particular industry. And I suggest many of our listeners and viewers here in the UK maybe not so familiar with the world of American college sport, but that's certainly where you got your start. Can you tell us a little bit about how that journey began?
Yeah, when I was in college, or I guess in the UK, as they say, university, I went to the University of Washington and I played American football. Um, American football is a top tier sport. So, football, baseball, basketball, and it is a big time sport. So, if you play at a major university, then you play, against the likes of Ohio States and Michigans, the Georgias, the Miamis. And so I played at the University of Washington when I was in university or college.
And it was, I understand that there was a kind of a not so much a tussle, but a kind of like a battle between trying to pursue a sporting career, but also gifted academically as well. Did you find there was a kind of well, not so much a disconnect, but that those two things were competing against one another?
Oh, absolutely. I mean, there are two different universes. So in one universe is kind of an alpha male sport. I guess not kind of, it is.
Mm.
And the king of the mountain or whatnot. And the other one, I guess the high intellect, you said I was computer engineering major. So that takes a lot of time, a lot of understanding, a lot of basic in mathematics. Um, and that, I guess I was able to balance the two because I was quite good at math. I also was quite good at football. So
Yeah.
I existed in two worlds at the same time.
I mean, thinking about growing up in the back in America, and certainly that those two competing interests. But what kind of you're obviously a sporty kid, but were you obviously a techie kid growing up as well? Were you the kind of person who would take apart computers or mess around with QBasic? What were you like growing up?
I would say I had a balance. My mom was a math teacher, and so I was always around math. And we had a early computer, a Mac, in the late '80s and going into the '90s. I also grew up around Portland, excuse me, which is called Silicon Forest. So not Silicon Valley in San Francisco, but Silicon Forest because Intel was based there.
Yeah.
So in some sense, we are surrounded by technology. I did like to take toys apart and put them back together, but I was not. I actually did not program until I got to the university. So that was my first experience programming was at the university.
Okay. So obviously from there, the interest picked up, and I guess the love and the interest kind of gained. What was do you remember the first languages you kind of started learning and realize actually this is more than just an interest. This is a calling.
Yeah. So two languages actually. So one of them was C. So my very first programming language at the university. This was computer science or CS 142 at University of Washington. They taught that in C. And so that was my very first language, and I found it quite exciting. Today, we don't even teach C for the first programming language because it can be quite difficult for people. But I I found it very exciting. I also my first internship, I had to program Excel spreadsheets. So basic was what I learned there. So essentially C and basic were my first languages that I learned.
Yeah. And from there, obviously graduation, you ended moving more towards a career in academia rather than pursuing sport. What was it just more of a natural thing that the study of the theory and the science behind it, really took hold? Why the move to academia?
Yeah, so I would say I didn't know that I wanted to do that when I was in the university. I thought that I was going to graduate and go to the Google at the time, which was Intel.
Mhm.
Um, get married and have two kids and move on. But what happened was because I was an athlete and played football, and I did very well in the university. It was recommended that I apply for a Rhodes Scholar, which actually is a connection to the UK because if you become a Rhodes Scholar, you go to Oxford. And
Mhm.
so I applied to be a Rhodes Scholar, and I was selected at the university level, and then at the state level, and then there's 8 different regions, and they select 4 people from each region, and I was not selected
Mm.
at that final stage. However, I had put together a what's called a statement of purpose. I had letters of recommendation, so I had described what I wanted to do um, postgraduate, and so I decided that, in fact, to go back a little bit, I was playing at my last football game, which was in Hawaii, so it was a Oahu Bowl, and it was on Christmas Day. And so the day after Christmas, after I had found out that I wasn't going to be a Rhodes Scholar, I was thinking about, what do I want to do? Um, and it was actually at that moment, the day after Christmas, that I decided that I was going to go to graduate school.
Mhm.
And so when I got back, I then applied to Berkeley and a whole bunch of other schools, and ultimately ended up going to Berkeley.
Mhm.
Um, One other thing that I'll say before that was I did have a research experience. So this was in the 90s, and not everybody had a website at the time. So my research experience was to write a wrapper that could ingest information from websites and then put it into a database. So it was a database research. The person who was my academic advisor for that was his name was Alon Halevi, and the student was Zach Ives, who's actually the chair of the University of Pennsylvania right now.
Mhm.
So I didn't realize it at the time, but I actually was walking in the footsteps of some giant researchers, and I ended up you know almost accidentally going to graduate school at Berkeley. At that point, I fell in love actually with research. Um, if I say a little bit about that, I this was 1999 at this point, and my advisor at the time was worried about losing information. So he had a laptop when he was writing his PhD thesis, and he was worried that if he dropped it, he may lose his entire thesis. So he dreamed up this project called Ocean Store, where we would store the world's information forever. So when I joined Berkeley, we actually wrote about this. It was a fairly large group. That paper was published, and that paper became the blueprint for cloud storage. So your Amazon, Google's, Microsoft would refer to this paper, that I helped to write in 1999 as the blueprint for exactly what we do today, which is store most of the world's information. The last in the cloud. The last thing I'll say about that is nearly 20 years later, that paper received a Most Influential Paper Award. So it received a 2018 Most Influential Paper Award from um, a conference,
That's,
ASPUS.
I mean, that is not to say this is. It's almost redundant to say that's revolutionary, but in 1999, we're talking about Pentium ones. We're talking about the idea of having more than say 500 megabytes of hard drive space is like insane. To be even contemplating a world of cloud storage, that is beyond next level. Is there times when you look back on it and think there's so much of what we're doing now in terms of cloud technology and data storage that was not just something that's just sprung up in the last decade, perhaps even more, but the genesis of that was way back then. Does that surprise you? Yeah.
Uh, it does. So I mean, I would say that as a researcher in a university, your job is discovery. So we are working to contribute to the unknown. And so at the time, Google started in 1998. This
Mm.
was 1999, and we were talking about storing what's called a mole of bytes, so Avogadro's number, 10 to the 23. um, and if you think about it, there was 10 billion people in the world, let's say. Each person has, 10,000 files. Each file is a gigabyte. That's 10 to 24. So it was revolutionary because we were trying to store an unimaginable amount of data.
Mm.
And Google had barely even got started at the time. And here we are 20 years later, and we are storing just about as much as that, as we just described there. And so you have to have a mindset of discovery in order to do that. Now, how that relates to the company
Mm.
is, in some sense, uh, the group that I was a part of, and the group at Cornell University as well, feel some type of responsibility of, laying the blueprints for part of the cloud. Um, and at the same time, we then feel some responsibility to tame parts of the cloud. So that's what Exotanium does when we get into that. Um, One thing I will say about the discovery phase. So actually, the University of Cambridge also has a lot to say about the cloud as well,
Mhm.
because there's a software that was designed at Cambridge that is also part of Exotanium, that is part of the blueprint of the cloud, and that's called Zen. So
Mhm.
if you look at the Zen virtual machine hypervisor, that was created in 2003 at University of Cambridge. It was downloaded by Amazon um, around 2005. And the person who essentially did that was a person named Werner Vogels. And Werner Vogels was a researcher at Cornell beforehand. He had a startup with our co-founder, Robert Baronese, and they created a company that they sold to Amazon. And Werner became the CTO of Amazon and effectively created Amazon Web Services.
Mhm.
So in all this creating, trying to contribute to new ideas, there's multiple ways that, I individually and us as a company, some of the founders have contributed to that foundations of the cloud, both storage and compute.
Absolutely. Uh, you touched on that the company is called Exotanium. It's everything. A career in academia kind of sort of has become blossoming. It blossomed into a career within the tech sector itself. That started around. It was in 2018. It was founded, wasn't it? Exotanium.
Correct. Yeah.
So could you tell me a little bit about the opportunity there? What was it about, you know, pursuing both a career in academia and now a career in within the tech space too? What was the opportunity you saw?
Yeah. So to connect things, if you fast forward from 1999, that's when we created this ocean store clouds, essentially early blueprints for cloud storage. And then you had 2003, you had Zen. A couple years later after that, you had Amazon Web Services. Okay. And then by the 2010s, you had cloud for Amazon, Google, Microsoft. And one of the things that we were concerned about was being locked into the cloud. So my research lab, um, more than 10 years ago, came up with the capability of how you actually start an application in one cloud and then migrate it live to another. So actually 10 years ago, we had a thing called Zen Blanket. Remember I mentioned Zen came from Cambridge. So this was Zen Blanket, and it allowed you to start an application in Amazon and then migrate it to Google and then migrate it to Azure.
Mhm.
And so that was called Zen Blanket. We then, in my lab and with the other co-founder, Ziming Shen, created a thing that we called a super cloud. So this allows you to essentially create what you would call your own infrastructure as a service cloud. So it gives you the look and feel as if you own your own infrastructure,
Mhm.
but it's all virtual. It's all
Mhm.
on top of Amazon, Google, Microsoft. And then if you now talk about Exotanium, then what we wanted to do was initially we thought it would be a multi-cloud approach like I just described. But what we ended up doing after a lot of customer discovery was figuring out that we could use the same technology for what we call cloud optimization. So that means that instead of paying, one of the cloud providers $1, we have ways to reduce that same to get the same performance done that cost to 30 cents or 20 cents.
Mhm.
So we can get the same job done um, for 5 times less, 3 to 5 times less, or have 3 to 5 times the amount of compute. But the key here is that the way it related to the earlier parts of the discovery and whatnot was, in some sense, we feel like we had unleashed the beast, if you will, with if you call the cloud the beast. And then with some of the later technology, we were looking at how we can actually control the beast, or rather, give control back to the user.
Mhm.
So whoever's using the cloud can use it in whatever way they see fit. And so that's what Exotanium does today. Is really, in some sense, is about control.
Yeah.
If the user can control their virtual machine servers in the way they want, and ultimately even to move it across cloud providers, then
Mhm.
that means that you can use it in such a way that you can significantly optimize your use of resources, or reduce costs. So you can use cheaper environments, you can use a smaller number of underlying virtual machines, you can change the size of the virtual machine, and all without interrupting the application. Those really are basic ingredients of significantly reducing the cost.
Absolutely. Oh, I think one of the things that a lot of businesses who are embracing cloud technology and certainly bring that on board, is they find that there is that, I wouldn't say reliance on one source, but there is that sort of concern that there's, there are potentially reliability issues, running multiple applications across the cloud. How do you ensure that you can continue running your programs, you're running your business across these different cloud storages? How do you keep that machine running?
Yeah. So I guess a couple things. Number one is for the business, Exotanium is focused on compute as opposed to storage. So it's focused on the server itself that's doing the computation. Number two, the cloud itself provides some level of reliability. Usually they'll say like 4 nines, and what that means is about 1 out of 1,000 jobs may get terminated, or about
Mhm.
1 hour out of the year, Amazon or Google or Microsoft or whoever may not be available, or at least some region of it. And so, essentially, as a company, and as the products that we provide, we're essentially providing the same level of reliability, or the near amount. So we're not actually what you would call replicating the application, which is what you
Mhm.
would do for reliability to increase it, but rather we are moving the application to optimize how much resources consuming, or how much it may cost or whatnot. But it's the same application.
Yeah.
We just have enough control of it that we can move it around. The last thing I'll say is, even though we have the ability to move it between different clouds, the main product that we provide right now is leaving it within a cloud, within the same cloud and the same what's called availability zone. And the reason for that is, if you migrate across clouds or availability zone, you incur a cost. There's a cost in latency, and there's a
Mhm.
cost in money
Yeah.
to move the data elsewhere. If you stay in the same availability zone and you move your application around, then there is no extra cost in latency, and there's no extra financial cost as well. So our first set of products stay within the same availability zone, and we're able to extract out really some unimaginable and unprecedented amount of resource squeezing and savings, um, and not only without reducing performance at all, but sometimes actually getting an increase in performance. That means the job gets done a little bit faster.
Yeah,
So
I was going to ask about performance and how do you ensure that not only are you losing things, but like you've just said, you're being ahead of the curve. How does that
yeah,
happen?
yeah. So a couple things. So uh, we we often try to be conservative when we're talking to clients. So we would say, you should expect a single percent overhead. So that means if it took 10 hours, it may actually take 10 hours and 20 minutes. Um, but there are cases where we actually, instead of it taking 10 hours, it may take 9 or 9.5. So it's actually faster. And that's actually rooted in academia as well at the university. Um, is uh, if I talk about a little bit, it's actually part of the name. So there's these things called exokernels, um, and exokernel was a way of essentially packaging the operating system with the application. So people may have heard the term of library operating systems or unikernels. It actually started as an exokernel, and so an exokernel is a way of making the operating system part of the application. And if you do that, you actually can get some significant speed ups. And we have a way of doing that. Um, the unikernels that people know of today are slightly different. They try and optimize the amount of space that a application takes. We don't necessarily do that, but we are able to make the OS operating system into a library of the application and get significant speed up sometimes.
Yeah. I mean, it's rapidly evolving. I mean, it sounds like if we were to discuss the sort of the the nitty gritty details of how things are done, perhaps even 12 months, 24 months down the line, it will be almost not almost completely different, certainly in terms of not only performance, but scale as well. And I know certainly a lot of businesses, when they're talking about getting involved and using cloud, bringing the cloud into their day to day, perhaps some issues with sort of internally with maintaining it and sort of ensuring there's one person who is it becomes their thing to maintain things as well. Um, is the Exotanium sort of how do you kind of ensure that businesses are able to kind of keep their maintenance running?
Yeah. So here's the magic. We talked about a lot of, you know, a lot of the academic underpinnings for the technology, and it is a very deep technical stack. However, at the end of the day, the magic is that it's very easy for a business or engineer or user within that business to interact with the Exotanium product
Mhm.
because it's actually fairly transparent. It's as if the way that you start an application and manage and maintain it is the same process. And we actually haven't changed at all. And the reason we're able to get away with that is ultimately we are running our own virtual machine hypervisor. And so
Mhm.
what that means is a couple things. Number one, you don't have to change the application. Um, and this is surprising to people, but you don't have to change a single line of application. And as a result, we're able to support the application as is. And that also
Mhm.
means that if the application is 20 years old, 10 years old, 5 years old, brand new, we can support that. The other thing is that the way people manage their applications today, usually they're using some what's called an orchestration environment to start and stop and manage. They may be using Docker or Kubernetes or
Mhm.
Nomad, it may be called it, or many plethora of other orchestration environments. So we plug into that seamlessly. So when you start up a node, you would start up a node like normal. It may just be a special node, Exotanium node that then gives you the power of migration and being able to optimize your resources of the cloud. So in terms of maintenance, that is really where the power of the Exotanium software comes in because it's
Mhm.
the normal maintenance, the normal operations that you would do, but then you get this extra power. So we like to say, raise it to the power of X, for example, Exotanium.
Absolutely. And you've secured $5 million in seed funding. I mean, certainly it sounds like you're primed to scale. And you've talked, kind of alluded a little bit about the kind of tech stack you're working with. And so I imagine the kind of developer you would be looking to bring on board would need to be able to bring cope with that and work with that. Can you sort of paint me a picture of what you see the next 12 to 24 months looking like for you guys?
Yeah, absolutely. So we raised a what's called a Series Seed last year in 2021. So that was $5 million. We grew from 5 to 25 people last year, so we grew by more than 5x. And then we've also been able to increase our engineering and production such that we also have several clients now that have range from startup companies to more traditional multi-billion-dollar revenue companies. And so over the next 12 to 18 to 24 months, what we'll do is scale that engineering so that we're able to increase the number of customers. Right now, we have, like I said, several. We want to increase that by order of magnitude. So a lot of what we're doing in terms of go-to-market and customer market fit will be uh, uh, growing that go-to-market team, but also on the engineering side, which you mentioned, um, we do have quite a bit technical stack, and so we hire people who not just know Python and whatnot, but know Go, know C, C++, know what a thread is. We have a fairly complicated distributed system, and so you have to be able to imagine that system, and you need to be able to create new pieces of it and design and debug it and whatnot, and understand what's going on.
Mhm.
So when we hire, we look for that, some of that understanding, which most people with a computer science degree or maybe 5 years of experience, have that level of understanding. And then also in the next 12 to 18 months, we've been focused right now on Amazon. And in that time, we'll grow to the other hyperscalers, so Azure and Google. Fundamentally, it already works there,
Yeah,
but be able to scale with the same reliability, um, will take some time. Financially, we'll also um, pursuing the next round is called a Series A raise, and each year, essentially, you want to be able to raise another round. So we'll be doing that this year. Yeah, and then we look to be able to scale another, you know, 2 to 4x in terms of people, in terms of customer, another 10x, in terms of performance and ease of use and whatnot as well.
absolutely. I mean, it's certainly it's when a business is in this position and all you can see is wide open spaces. It's exciting, and I think when you kind of thinking about building the business, is not only the side of ensuring that the tech stack is good and that the product is good as well, but is certainly like on this side of the Atlantic, the competition for engineers and for tech talent is about as rabid as it's been probably ever. I think certainly there are developers who not to disparage them, but perhaps some who were enjoying a certain amount of prestige in their careers, and all of a sudden, just in the last 12 months, they're finding jobs with salary increases of 20, 30,000 pounds. And certainly the competition for talent is rife. Uh, when you think about the kind of company you want Exotanium to be, just from like a cultural perspective, more than beyond the kind of the product, what's the kind of vision? What's the kind of culture you're trying to build?
Yeah, so absolutely. So a couple things. Number one, this is an amazing time to be a software developer. Like you said, the competition for the software developer is sky high.
Mm,
And I did live there in Cambridge in the UK for a year. And
yeah.
at the time, this was 2015, 16, the unemployment was, 2 or 3%. And now I'm not sure exactly what it is now, but the competition is amazing.
Mm,
And relating to culture, we're able to win a lot of those battles for getting software developers because we're an exciting place to work, technology wise. Nobody can, well, I don't say nobody can compete with us, but we have very exciting technology. We have unprecedented capability. Culturally, we are very diverse as well and very inclusive. environment as well. So we have people that have families, have a lot of experience. We have people straight out of the university. We have people from different countries and different backgrounds
Hmm.
and different genders. And so we really believe that the diversity creates strength, because you have a diverse set of minds and point of view, and they're all contributing. So a couple things there: the culture there, the technology, um, also people. It's a startup, and so our survival is based off of everybody's contributions. So it's very different than much larger company, and all that really makes for a fairly exciting time in people's lives, a very exciting place to work, a fairly, I want to say, warm environment as well. We have a lot of families, people who have families, but at the
Hmm.
same time, it's very competitive. And
Yeah.
if I go back to the beginning of our conversation, which is when I played football. Football is very competitive, right?
Mm.
We're playing against some of the biggest teams and the biggest people in the world, and you play to win. But I would say, as a company, we don't want to lose sight of winning over people. So I would say people are the most important. Enjoying what you're doing is the most important. If you don't enjoy it, why do it? And everybody, loves what they're doing. Um, Otherwise, this is a good time to switch.
Mm.
So I would actually encourage people to look us up at Exotanium if they're interested in, exciting and new opportunity, either as a potential person working with us, or potential business as well, to check out our products.
Absolutely. And just finally, but before we wrap up, if they're a business and you're thinking about adopting the cloud-based solution, and if you're thinking about how to incorporate uh, a solution like what Exotanium offers, what's one or two pieces of advice that businesses should have sort of front of mind before they embark on something like that?
Yeah, so if you're thinking about using the cloud, there's something called a modernization process. So there's a bunch of steps that people often go through. So usually they'll have their applications that are running what's called on-premise. Then they'll do what's called a lift and shift, which is that essentially allows you to virtualize your application. You may be running VMware software, so that you can move it around your own cluster. You'll then migrate that. Not, I shouldn't use the word migrate, but the lift and shift then allows you to move your application to the cloud. You'll
Mhm.
find out that it's very expensive. So we call it
Mhm.
like a lift and shift, oh crap, moment to figure out it's really expensive. Then
Yeah.
you'll embark in a process of monitoring and observing and re-architecting and reconfiguring and redeploying until you get to some microservice level, and then maybe you're starting to use containers, and then Kubernetes and stuff like that. And the
Mhm.
key about that journey, and well, for a company, you may have, you know, 1,000 applications. So of the 1,000 applications, some percent of that may be fairly advanced, some percent, maybe just getting started. The thing that I would say about Exotanium is we're able to be there every step of the way, which is that when you first do that lift and shift into the cloud, and you figure out, oh crap, this is expensive, we're able to, that day one, provide extreme savings without doing anything.
Mhm.
So it's like, you like lift and shift, and oh my gosh, this is amazing. So we provide an amazing, as opposed to oh crap moment. And then as you optimize and re-architect, all that is complementary. And the reason is that um, really we're at that operating system virtual hypervisor level. And in that sense, we're really kind of agnostic to the application.
Mhm.
And so that's where we help a lot of companies out on their journey. And from very large, and I'll mention in particular like the Department of Energy, which is huge in the United States, very large enterprise company, a lot of chip design, to very small. Um, we're able to benefit somewhere along that journey by using Expertanium.
Absolutely. And if you are interested in finding out more, look online at exotanium.com. And certainly where you're also on channels like LinkedIn and other sort of relevant social channels. Find out more about Exotanium and the solutions they provide. Hakim, thank you very much for your time today. A thoroughly interesting conversation. Certainly, when you think about the sort of the buzzwords in tech, and a lot of people, a lot of businesses think about cloud. It's good to not only know that this is a solution, but there's a way to make what could be potentially complicated technology user friendly and a lot more business savvy. And it sounds like Exotanium is well down the road to making that happen.
Michael, thank you. And thank you to all your followers and fans. I appreciate being here and having the opportunity to just discuss my personal journey and then also the journey of Exotanium and really how it potentially can be of service to anybody out there who may be interested. Thank you.
Absolutely. So that's all the time we have for this episode of Talking Tech. Tune in next time. We'll meet someone else who's moving and shaking in the tech space, either here in the UK or anywhere around the world. From me at